All right, now this is our last example in this section. We are going to use matrices to solve system of equations, linear equations below. And we are going to use augmented matrices, okay? So first of all, let's write the augmented matrix here. 3, 1, -2, 1, -2, 1. Of course, I have to write down these values as well. And 2, -1, -3 is equal to 3. Okay. Now, remember, we are allowed to do 3 operations. We can swap the rows. We can multiply a row with a scalar. And we can just multiply a row with a scalar and add it to another row, okay? And the main idea to solve system of equations with augmented matrices, I would like to get an identity matrix here, okay? So we have to start here. This is 3, right? I have to make this entry 1. I can either multiply the first row by 1/3 to make it 1 here, but I can also swap rows, right? I think it is easier. So let's swap the rows. Maybe I can write what I'm doing also here. So I can just swap row 1 and row 2 here. So 1, -2, 1. You should also take the entry on the right, 3, 3, -3, sorry, -3, 1, 1, -2, 2, 2, -1, -3, 3. Okay, cool. Now, what I'm gonna do, maybe I can use another color to show that. Now I want to make this entry and this entry 0, right? Remember, in the identity matrix, I have only ones on the diagonal and all other entries are 0. So the process of reducing this matrix to an identity matrix is just try to make this entry 0, okay? And how can I do that? I can to make this entry 0, I can multiply the first row by -3 and add it to the second row. And similarly, I can multiply first row by -2 and add it to the third row to make all these entries are 0, okay? So let me go to blue color again. Okay. Let me write what I am saying here. So that's actually equal to, not equal to, but maybe I can put a row. So I want to multiply, so row 2 will be actually row 1, or maybe I should say minus row 1, -3 row 1 plus row 2, right? I am multiplying the first row by -3 and edit that row. And row 3 will be -2 row 1 plus row 3. Okay, let me write down here what I am saying. So I don't do anything for the first row. And the second row will be 0, right? -3 times 1, -3 plus 3 is 0. -3 times -2 is 6, plus 1 is 7. This is 7. -3 times 1 is -3. -2 is -5. -3 times -3 is, -3 times 3 is 9. -9. Plus 2 is -7. But be careful, guys, because it's always possible to make some simple mistakes here in this row reduction. And for the next row, I'm gonna multiply the first row by -2 and add it to the second row, right? Third row. It is 0 here. What else? -2 times -2 is 4, plus -1 is 3. -2 times -2 times 1 is -2, plus -3 is -5. And -3 times -2 times 3 is -6, plus 3 is -6 plus 3 is -3. Okay. All right, so I could successfully have zeros here. Now the next step would be, what can I do here? So I have to make this entry 1, right? And how can I do that? I can just multiply the second row by 1/7. So row 2 will be 1/7 row 2. 1, -2, 1, 3, 0, 1. Okay, we have fraction right now. -5/7, -1, 0, 3, -5, -3. Okay, now I want to make this answer 0, right? How can I do that? I can multiply the second row. So row 3 will be second row by -3, -3, row 2, and add it to the third row, row 3. Okay. So what's that equal to? I don't do anything for the first 2 rows. 0, this will be 0, right? And -3 times -5/7 is 15/7. 15/7 plus -5. So 15/7, maybe I can do it here. 15/7 minus 5. If you had the common denominator, -35, -20/7, right? Okay. Yes, this is -20/7. Let me read this one. And for the last entry, I have to multiply this by -3 and add it to that. -3 times 1 is -3, 3 plus -3 is 0. Cool. Nice. So now I want to make this entry 1, right? Remember, the main diagonal should be 1. So let's multiply row 3 with -7/20 row 3. So it will be 1, -2, 1, 3, 0, 1, -5/7, -1. It's too long. 0, 0, 1, 0. Now I have to make this part 0 and that part 0, right? And how can I do that? Multiply. Okay, so row 2 will be multiply the row 3 by 5/7, right? 5/7 row 3 plus row 2 to make this answer 0, right? And similar, how can I make this answer 0? Row 1 will be equal to negative row 3 plus, oh, this is row 2, sorry. This is row 2, and this is row 1. Okay. So what do I have here? 1 minus 2. So this is 0. And this is 0, so it's not affecting that part. Nice. 0, 1, 0, -1, 0, 0, 1, 0. Almost done, right? If you look at the left-hand side, it's almost an identity matrix, but I have to make this -2 equal to 0, right? And how can I do that? I can multiply the second row by 2 and add it to the first row. So row 1 will be 2 row 2 plus row 1. Nice. So 1, 0, 0, and I'm going to multiply this by 2 and add it to that one, right? So what does it make? 2 times -1 is -2 plus 3 is 1. 0, 1, 0, -1, 0, 0, 1, 0. Yes. And remember, this is corresponding x1, or what are the variable names? x1, okay. This is x2 and this is x3, which means x1 is equal to 1, x2 is equal to -1, and x3 is equal to 0. Yeah, this is how you solve a system of equations, a system of linear equations using augmented matrices, okay? All right, this is why matrices are useful. Of course, this may seem kind of complicated, not complicated, but it's kind of messy. You know, you have to do all the operations one by one. But of course, you can consider that computers can do these operations very quick, right? or some other systems can do it very quickly. That's why solving system of linear equations using matrices are quite important. And this concept will be also quite important when it comes to solving ODEs. And we are going to talk about why this is important in solving ODEs in the next sections and videos. Okay, so for now, I'm going to see you guys in the next video. All right, take care, guys.